Welcome to the Chemistry YouTube channel. NEET Exam Chemistry Quick Revision Notes. First, atomic structure, physical chemistry. Energy of an electron in a species is given as En equal to minus 2 pi square me power 4 z square by n square h square. For in SI system, you have to add 4 pi epsilon square. For kilojoules in moles, it is minus 1312, that is 1312 z square by n square. It's very simple. And radius of an electron r equal to n square h square by 4 pi square m z e square. Simply 0.529 n square by z. Z is the atomic number, A is the Armstrong unit. Total energy of the electron in a shell, total kinetic energy and potential energy, which was given as minus k z e square by 2 Rn. If we take frequency, if we want to calculate the frequency and wavelength, formula is rz square by into 1 by n square minus 1 by n2 square. That is electron in n1 and n2. Number of spectral lines produced in an electron drops from nth level to ground is n into n minus 1 divided by 2. In Heisenberg uncertainty principle, it is delta x delta p greater than h by 4 pi. And if you want to calculate the total number of nodes, L is the angular momentum quantum number, n is the principal quantum number, n minus L minus 1 is the radial nodes. Orbital angular momentum is given as root of L into L plus 1 into H. Remember students, for s orbital L value is 0, for p orbital L equal to 1, d orbital L equal to 2 and f orbital L equal to 3. Radial probability density curve, for 1s orbital you will get 1 node for n equal to 1, for 2s orbital n equal to 2, so you will get 2 nodes. For 3s orbital it is you will get 3 nodes. For 2p orbital it's 1 node, 3p orbital is the 2 nodes, 3d orbital 1 node. Remember here, for 2s and 3p, for 2s and 3p you are getting 2 nodes, whereas for 1s and 2p you are getting 1 node. And 3d, 1s 2p 3d 1 node, 2s 3p 2 nodes, and 3s 3 nodes. Next chapter, chemical bonding. You are asked to calculate the percentage ionic character, which is given as actual dipole moment. Dipole moment value will be given and calculated dipole moment into 100. And you can also calculate the percentage ionic character using Pauling's equation, 100 into 1 minus exponential minus 1 by 4 xa minus xb. Xa is the one ion and xb is the another ion. Xa is the cation and xb is the anion. Fajan's rule. Now the following factors helpful in bringing covalent character of ionic compounds. For a compound to be ionic, it should be, cation should be very smaller in size and anion should be very larger in size, and high charge on cation bar anion. Cation having pseudo inert gas configuration, copper Cu plus, Ag plus, Zn2 plus, cadmium 2 plus. MO theory, bond order equal to 1 by 2, Nb is a bonding electron, Na is an anti-bonding electron. Higher the bond order, higher is the bond dissociation energy, greater is the stability, shorter is the bond length. You have to remember this concept. For example, H2 bond order 1, it's a diamagnetic, there is no unpaired electron. H2 plus, it contains one unpaired electron, bond order is 0.5. Li2 bond order 1, it's a diamagnetic. Relative bond strength, you remember here, sp3d2 is greater than dsp2. sp3d2 is octahedral, dsp2 is square planar, sp3 is a tetrahedral, sp2 greater than sp greater than pp orbital, coaxial sp, ss and pp, collateral. Vesper theory, lone pair repulsion is greater than lone pair bond pair repulsion, and which is greater than bond pair repulsion. Ammonia bond angle 106.45 because lone pair bond pair repulsion. Bond pair repulsion occurs in water molecule, it is 104.27. Okay. Bond angle, ammonia is greater than pH3 greater than ASH3. Water, the bond angle is greater in water than H2S than H2SE. Ammonia greater than NF3. Cl2O greater than OF2. Okay, next chemical equilibrium. Next chapter, Kp equal to Kc RT power ln n, del n, where Ng equal to Np minus Nr. Free energy change, delta G equal to 0 when reversible reaction would occur in equilibrium. Kc equal to 0 for a reversible reaction. Delta G is positive when the equilibrium is displaced backward direction. Delta G is negative when the equilibrium will displace in forward direction. Just remember these three concepts. They will ask more questions using this concept. Kc unit is moles per liter power del n. Kp unit atm power del n. Okay, next reaction quotient and equilibrium. Consider a reaction A plus B gives C plus D. It's a equilibrium reaction. QC equal to product by reactant. Product by reactant, case 1. If QC less than Kc, equilibrium constant value, then reactant will greater than the product. Then the system is not at equilibrium. Case 2, QC equal to Kc, then system is at equilibrium and the concentration of the species are at equilibrium. If QC greater than Kc, then products greater than the reactant. The product value will be greater than the reactant value. You remember the quotient and the denominator. The system is not at equilibrium. Okay. The relation between the equilibrium constant and the reaction quotient and Gibbs energy. Delta G equal to delta G naught plus RT ln Q. At equilibrium, delta G will be 0 and Q will be equal to K. Delta G equal to minus RT ln Kp ln Kc. You remember this, the Kc value and Kp value will be given. You have to calculate the del G value, delta G value. Next, Lecharty principle. Increase of reaction concentration shift the reaction towards forwards. Decrease of reactant concentration shift the reaction towards backwards. Increase of pressure from more moles to less moles. Decrease of pressures, if you decrease the pressure of the reaction from less moles to more moles, more molecules will be formed. More molecules comes close to each other and more moles will be formed. If you increase the, for exothermic reaction, decrease in temperature, shift forward. For endothermic reaction, increase in temperature, shift backward. Lewis acid, electron pair acceptor. Next, acids and bases. Lewis acid is an electron pair acceptor. Example, CO2, BF3, AlCl3, ZnCl2, normal cation. Lewis base is an electron pair donor, ammonia, ROH, ROR, H2O, RNH2, normal anion. Dissociation of weak acid and weak base is given as Ka equal to Cx square by 1 minus x, or Ka equal to Cx square. Weak base, similarly for weak base, Kb equal to Cx square by 1 minus x. Buffer solution, Henderson equation, pH equal to pKa plus log salt by acid. For maximum buffer action, pH equal to pKa. For alkali, pOH equal to pKb plus log salt by base. pH equal to pH 14 minus pKb. For buffer capacity, moles per liter of acid or base mixed divided by change in pH is a buffer capacity. Ionic equilibrium, next chapter. Necessary condition for showing neutral color of indicator, pH equal to pK ln, which is equal to indicator relation between ionization constant and degree of ionization, K equal to alpha square by 1 minus alpha into V. This is also dilution law, alpha square C divided by 1 minus alpha. It is applicable to weak electrolytes which is alpha less than 1. Here you see common ion effect. The addition of X mole per liter of a common ion to a weak acid or a weak base become equal to Ka by X or Kb by X, where alpha is the degree of dissociation. If solubility product greater than the ionic product, then the solution is unsaturated and more substance can be dissolved in it. If ionic product greater than solubility of the product, the solution is supersaturated. Principle of precipitation. Salt of weak acid and strong base. pH equal to 0.5 pKw plus pKa plus log C. H is equal to Kh by C. Kh equal to Kw by Ka. Salt of weak base and strong acid, pH equal to pKw minus pKb minus log C. Salt of weak acid and weak base, pH equal to 0.5 pKw, both pKa minus pKb. You just add these two equations and H equal to root of Kw Ka into Kb. The difference between molecularity and order of the reaction. Order of the reaction, it is experimentally determined. It is theoretical concept. It can have integral, fractional or negative value, but here always the integral value is 0, never 0 or negative. It can be obtained from a balanced or stoichiometric equation. It can be obtained. It tells about the slowest step of the mechanism. It does not tell anything about the mechanism. It is the sum of powers of concentration of terms in the rate law of the equation. It is the number of reacting species undergoing simultaneous collision in the reaction. So this is a difference between order and molecularity of the reaction. Unit of rate constant, K equal to mole per n minus 1 liter per second. Moles per liter per second. Order of the reaction can be fractional, 0 or whole number. Molecularity reaction is always a whole number. It is never more than 3. It cannot be 0. For first order reaction, this equation we remember is K equal to 2.303 divided by T log A by A minus X. T of equal to 0.693 by K. AT equal to A naught e power minus KT. So second order reaction where A and B are gives product, K2 equal to 1 by T X into X divided by A into A minus X. When concentration of A and B are taking different, when for different moles of concentration, that is A plus B gives product, K2 will be equal to 2.303 divided by T A minus B log B into A minus X divided by A into B minus X. For zero order reaction, X equal to KT. T of equal to A by 2K. The reaction of the rate of the reaction is, remember here, it is independent of the concentration. For time, for nth fraction of first order process, T 1 by n equal to 2.303 by K log 1 by 1 minus 1 by n. Arrhenius equation, you have to remember this, K equal to A into e power minus EA by RT. Slope equal to is if you draw a graph, you get a slope like this. Here this slope dy by dx, this dy by dx equal to minus Ea by 2.303 into R. Temperature coefficient log K2 by K1 into is an integrated rate equation equal to Ea by 2.303 T2 minus T1 T1 T2 for two different temperature. If they are given two different temperature and they are asked to calculate the Ea value. Next, it has been found that for a chemical reaction which rise in temperature by 10 degree, the rate constant got nearly double. Next, oxidation reduction reaction. Oxidant itself reduced gives O2, or oxidant is a electron acceptor. Reductant itself is oxidized to give H2, or reductant is a electron donor. Strongness of an acid is directly proportional to ON. Strongness of a base is directly proportional to 1 by ON. Electrochemical series, lithium, potassium, barium is an electrochemical series. You just remember, as we move from top to bottom in this series, standard reduction potential increases, standard oxidation potential decreases. You remember this one. Reducing capacity decreases, ionization potential increases, reactivity decreases. Remember, in volumetric analysis, equivalent weight of an element is equal to atomic weight of the element divided by valency of the element. Law of Dulong and Petit atomic weight into specific heat, nearly equal to 6.4. Normality, N equal to number of equivalents divided by volume of solution in liters. Molarity, number of moles divided by volume of solution in liters. Common acid base indicator, remember, methyl orange, red color, alkaline, yellow color, pH range 3.2 and 4.4. Methyl red, pH range 4.2, 6.2. It is when it is a litmus, it is 4.5 to 8.3 pH range. 8.3 to 10, it is a phenolphthalein indicator. Acid, it is colorless. Alkaline, it is a red color. And thermodynamics, next chapter, thermodynamics. First law of thermodynamics. First law, delta E equal to Q plus W. Q minus W, expression for pressure, W equal to minus PD. Maximum work done, W equal to minus 2.303 NR log V2 by V1. In terms of pressure, it is minus 2.3 nRT log P1 by P2. Here volume is V2 by V1. Remember, in terms of volume it is V2 by V1. In terms of pressure it is P1 by P2. W, work done in a reversible, will be greater than the work done in the irreversible condition. QV equal to CV delta T. Delta U, QP equal to CP delta T. It is equal to delta H. Enthalpy change during phase transformation. Enthalpy of fusion, heat of vaporization, heat of sublimation. Enthalpy delta H equal to delta E into P delta V. Delta E plus delta NG RT. Kirchhoff's equation, delta E T2 equal to delta E T1 plus delta CV T2 minus T1 at a constant volume. At a constant pressure, it is delta Cp T2 minus T1. Entropy, measure of disorder or randomness, delta S equal to delta Sp minus delta Sr. Delta S equal to Q by T, which is equal to 2.303 nRT log V2 by V1, 2.303 nR log P1 by P2. Free energy change, delta G equal to delta H minus T delta S. Yes, remember this table. It's a very important table. Delta H is minus, delta S is plus, entropy is plus, then delta G is always negative. Reaction is spontaneous at all temperature. When for a reaction is non-spontaneous, that is a reversible reaction, delta G is positive, delta S negative, delta H is positive. Spontaneous at low temperature and non-spontaneous at high temperature. In this reaction condition, delta G negative at low temperature but positive at high temperature. Delta S is negative and delta H is negative. And then when reaction condition non-spontaneous at low temperature and spontaneous at high temperature, it is just reverse, positive at low temperature and negative at high temperature. And delta S is positive and delta H will be positive. You just remember this table. It's a very, very important table. We are given in a nutshell. Electrochemistry. M equal to ZIT, degree of dissociation, alpha equal to lambda at lambda infinity. Equivalent conductance at given concentration, equivalent conductance at infinite dilution. So specific conductance, you remember, specific conductance equal to 1 by S, 1 by R A into L, L by R A. L is the length of the cell and A is the area of cross section and R is the resistance. And equivalent molar conductance, molar equivalent conductance equal to 1000 divided by C. C is the concentration of the solution into specific conductivity. Kohlrausch law, it's delta M equal to X into lambda A, Y plus Y into lambda B. Nast equation, E equal to E naught minus 0.591 divided by N. N is the number of electron transferred, log product by reactant is a Nast equation. And E cell equal to E cell right plus E cell left and K equilibrium equal to antilog of Ne dot by 0.0591. Delta G equal to minus NF E. Delta G equal to minus NF E cell. And the work done in the cell equal to NF E and delta G equal to delta H plus T dou G by dou T. Calculation of pH of an electrolyte by using calomel electrode. pH equal to E cell minus 0.2415 is a calomel voltage divided by 0.0591. Thermodynamic efficiency of a fuel cell is given as eta equal to minus delta G by delta H, or delta G is given as minus NFE, so it can also be given as minus NFE cell divided by delta H. For hydrogen oxygen fuel cell, it is 90%. Now the solution and colligative properties. Raoult's law, P equal to PA plus PB, which is equal to P naught XA into P naught XB. XA and XB are mole fraction. Characters of an ideal solution. Delta V equal to 0, delta H equal to 0. Relative lowering of vapor pressure, PA naught minus PA by PA naught, which is equal to colligative is directly proportional to number of particles. That is, colligative property means it depends on concentration of the ions, number of ions, number of moles in the solid. Diffraction of freezing point, TF, delta TF equal to KF into M. Elevation of boiling point, you remember this formula, delta TB equal to 1000 kb by M1, P0 minus P by P0. Osmotic pressure with the depression in freezing point, delta TF, P equal to delta TF into DRT by 1000 KF. Relation between osmotic pressure and another colligative properties. Pi equal to PA minus P0 A minus PA by PA0 DRT by MB, relative lowering of vapor pressure. Pi equal to TB, delta TB into DRT by 1000 kb is a elevation in boiling point. Pi equal to delta F DRT by 1000 kF is a diffraction in freezing point. The same formula, so elevation point, the freezing point. I, concentration equal to number of normal molar mass divided by observed molar mass, or observed colligative property equal to normal colligative property. I equal to observed osmotic pressure by normal osmotic pressure. Degree of association, A equal to 1 minus I into N by N minus 1. Degree of dissociation is alpha, is given as I minus 1 divided by N minus 1. Next, gaseous state. Ideal gas equation, PV equal to nRT. R equal to 0.081 in liter atmosphere degree per mole. R equal to 2 in calories. R equal to 8.314 in joules per kilogram per mole. Velocity, this relative velocity, you remember this one. RMS velocity 3 PV by M or 3 RT by M. Average velocity is 3 RT by 8 RT by M. Most probable velocity, it is 2 RT by M. You relate this average speed equal to 0.9213 into RMS speed. RMS speed equal to 1.085 into average speed. Most probable velocity is given as 0.816 into RMS. RMS equal to 1.224 into most probable velocity. So it's a relation, it's a ratio. Rate of diffusion is directly proportional to 1 by square root of density of gas. Van der Waals equation, it is P plus A by V square. When N equal to 1, you will get P plus A by V square plus V minus B equal to RT. For N is the number of moles. Z, compressibility factor, PV by nRT. Z equal to 1 for ideal gas. When Z equal to 1, PV will be equal to nRT. Solid state and liquid state. Available space filled up by hard spheres. Simple cubic, it is pi by 6. And BCC, pi root 3 by 8, 0.68. FCC is 0.07. HCP, it is 0.0474. Diamond, it is 0.034. Here you remember this radius ratio. When radius ratio, that is the radius of cation divided by radius of anion, is a radius ratio. When it is in the range 0.155 to 0.225, coordination number is 3, then it is a plane triangle. So 255 to 0.414, coordination number 4, it is a tetrahedral. 0.414 to 0.732, coordination number is 6, it will be octahedral. 0.732 to 1, it is coordination number 8, it is BCC, body centered cubic. Atomic radius R and the edge of the unit cell for a pure elements, a simple cubic, R equal to A by 2, BCC, it is R equal to root 3 by 4, root 3 A by 4, FCC, it is root A by 4. Relation between radius of void and radius of sphere. Tetrahedral 0.225, octahedral 0.114 into R. Paramagnetic, presence of unpaired electron attached to magnetic field. Ferromagnetic, it is a permanent magnetism. Antiferromagnetic, it is a net magnetic moment is 0. Ferrimagnetic, net magnetic moment is 3. You remember this one. Surface chemistry and colloidal state. Emulsion, colloidal solution of two immiscible liquids. Emulsifier, long chain hydrocarbons are added to stabilize emulsion. Lyophilic colloid, gelatin have greater affinity of the solvent. Lyophobic colloid, no affinity for solvent. Special methods are used to prepare the salts. Example, Ag2S3 FeOH thrice. Preparation of colloidal solution, dispersion method and condensation method. Properties of colloidal solution, so Tyndall effect, Brownian moment, coagulation, filtrability. This is about physical chemistry.